Welcome back again for the second part. So for second part, we will be discussing about the Cartesian vectors. So for the Cartesian vector, if you are confused how to solve, we can use the right-handed coordinate system. So a rectangular coordinate system is said to be a right-handed if the thumbs of the right hand points in the direction of the positive g-axis. When the right hand fingers are curled about this axis and directed from the positive x-axis towards the positive y-axis. So thumbs will be in the g-axis, the curled fingers will be the x-axis, while your arms will be the y-axis. So in this one, since it's a 3 coordinates, so that means the 3 directions and the fixed vector, because it will indicate you the fixed point, it will direct you up to the fixed point. So rectangular components of the vectors, so you can solve by using the sum of those 3 axes, the vector in the axis x plus vector in the axis y and the vector in the axis g. That should be equals to the resultant vector A. Cartesian unit vector, you can use I, vector j, unit vector I, unit vector j, and unit vector k as well. So while you represent this given vector, rectangular component of the vector, in the Cartesian unit vector, it will become axi plus ayi plus azk. And to solve the magnitude of this Cartesian vector, you can use the formula, that is A equals to, same again, root under ax square plus ay square plus az square. So the magnitude of vector A is equals to the positive squares of the sum of the squares of its all component in the x component, y components, and z components. Then coordinate direction angles, the direction of the vector A can be solved by coordinate angle A or alpha, beta, or gamma that will be measured between the tail of the A and positive x, y, and z axis, provided that they are all located at the tail of vector A. So A will be the angle, alpha will be the angle that vector A will be making with x-axis. Beta will be the angle that the vector A will be making along the y-axis, and gamma will be the direction of the vector that will be making the angle along with g-axis. So it will direct you to the exact one point. That's why, as we mentioned in the previous part, there are 3 types of vector: unit, free vectors, fixed vectors. So this is one of the example, which is fixed vector, because it will give you the specific coordinate. So these numbers are known as the direction cosines of the vector A. Cos alpha should be ax, or the component of x-axis, by vector A. Cos beta should be y component of vector A divided by A. And cos gamma should be the vector, since it's acting along the z-axis, so az divided by A, the vector A. So they are the direction cosines of the fixed vector A. So the coordinates direction angle can then be determined from the inverse cosines as well. Just inverse the cos to the right hand side. So alpha can be measured by cos inverse ax by A. Beta can be measured by cos inverse ay by A. Gamma can be measured by cos inverse az by A. Simple as that. Then an easy way of obtaining this direction cosine is to form a unit vector UA in the direction of vector A. UA can be equals to A vector A divided by magnitude of vector A. So that should be equals to AXI unit vector divided by AY over A unit vector J plus AZ by A unit vector K. So substitute this AX over A from the equation that we got in the previous slide, this one. So AX over A, that's cos alpha, AY over A cos beta, AZ by A, that is cos gamma. So we just replace here AX over A replaced by cos alpha, AY by A replaced by cos beta, AZ by A replaced by cos gamma. Then it will retain the unit vectors. Here. So we have a formula, cos square alpha plus cos square bravo plus cos square gamma, it should be equals to 1. That's a formula. So E should be equals to AUA. AUA we have here. AUA, we just substitute to this part. So the remaining is vector A, which will be equals to magnitude A times, we are substituting, this is the formula as well, we are just substituting the value of unit vector UA. So after substituting, we just multiply all the terms by the common which is magnitude of vector A. So it will become, again we replace cos alpha I replaced by here A cos alpha, it should be equals to, here we go back again here, A cos alpha, that is equals to AX, here AX is equals to A cos alpha, A cos bravo, that is AY, same here, A cos beta, sorry, not bravo, beta, or A cos beta, that is equals to AY, A cos gamma, that is equals to AZ. So that is why we replace. So we get back this Cartesian vector again. Then we have another topic, that is transverse and azimuth angles. Sometimes the direction of the vector A can be specified using the two angles, namely a transverse angle theta and the azimuth angle phi. So theta is the angle made by inverse vector A to the along the x axis and gamma along the z axis. So applying the trigonometric first to the light blue triangle, which is AZ equals to A cos phi here, which is A inverse, that should be equals to A sine gamma. A inverse here, this is our A inverse. Then now applying trigonometric to the dark blue right side, right triangle, dark blue, this part. So while applying the trigonometry in that part, AX should be equals to A dash cos theta. Here AX should be equals to opposite, that is normally usually cos theta is equals to base open hypotenuse. Base is AX by hypotenuse A dash. So when cross multiply, you will get the answer of A dash cos theta. Then that is also equals to A dash cos theta. A dash sin theta is equals to A dash. So we substitute the value of A dash, that is A sin phi. So we just substitute the value A sin phi cos theta. Then similarly AY also same in the same dark blue triangle. AY is the perpendicular, so cos sin theta is equals to perpendicular over hypotenuse. Perpendicular is AY, then hypotenuse is A dash. So when you cross multiply, you will get is A dash cos theta is equals to AX. So again, same from here, A dash sin theta. So A dash, we have a value already, A dash sin phi, substitute. So you will get the answer A sin phi sin theta. So once you get that one, we have vector A should be equals to unit vectors again, Cartesian product, A sin phi cos theta coming from here, A sin phi sin theta j coming from here, then A cos phi coming from AJ, then K. Then addition of Cartesian vectors again, AXI plus AYJ plus AZK, B equals to BXI, B plus BYZ plus BJK. Then the resultant vector is as usual addition of the two vectors A and vector B. So that can also be represented in the Cartesian vector AX plus BX I AY BYJ plus AZ along the components along the z-axis of both vectors will be in times unit vector k. So which is ax plus bx, which is the sum of components along the x-axis, ay plus by, which is the sum of components along the y-axis, az plus bz, which is the sum of components along the z-axis. So it can also be indicated in this form. So we have 3 more examples. So let's solve with the example number 7. So express as per example number 7, it's asking to express the force F shown in the figure below as a Cartesian vector and find the coordinate angle. So simple again, we just use the same formula again and again. So the value for the force F is given 100 pounds, and it makes the angle along the x-axis, along the y-axis. Along the x-axis, it's making 45 degrees, and along, yep, that's correct. So we make a diagram, free body diagram. So Fj, by using this diagram and the formula that we have here, so it will become here Fg equals to A sin theta sin 60 pounds, which is 86. Just substitute the value that you have comparing with the drawing that you have here. This will be your basis for your computations if you are confused to solve by yourself. So just substitute the value. Fg 100 sin 60, F dash 100 cos 60, which will be 50 pounds. Fx should be F dash cos 45, that is 50 cos 45, because we already got F dash the value 50 pounds. So the Fx, the value of Fx will be 35.4 pounds. And then the value for Fx will be F dash sin 45. So F dash is 50 sin 45. That will be equal to 35.4 pounds again. So that is the coordinate Cartesian vectors. So F is equals to Fxi plus Fyj plus Fzk, realizing that Fy has a direction defined by negative j because it's working along second quadrant. Sorry, F dash, it's along third quadrant. Am I right? Yep. So in third quadrant, y is negative, so we just replace the sign, negative sign here. So that will be the representation of the vector in the Cartesian form. So to show that magnitude of the vector is indeed 100 pounds, you can prove it by substituting this values in the formula that we have, which is f is equals to sum of square root of fx square plus fy square plus fz square. We just substitute the value, we get 100 pounds, which is the value we have here. So that means the problem or the answer we have is correct. So by using the formulas again, we need to find the coordinate angles again, because the question is asking for the coordinate angle. So how many coordinate angle do we have? We have 3 coordinate angles, alpha, beta, and gamma. So same formula again, u is equals to f over f, fx, fi, fy over f, j, fz over fk. Substitute the value of respective fx, fy, fz. F is already given, 100 pounds. So u is, unit vector u is here. Then alpha, angle alpha is cos inverse 0.354. Beta is 180 minus cos inverse here. Then gamma is cos inverse 0.866, which is 30 degrees angle. Here you might be asking why minus subtracted by 180 degrees, because here we have negative sign. Why negative sign? Go back to drawing again here. Similarly, we have example number 8. In example number 8, it's asking the questions to find the magnitude, coordinate, direction, and magnitude of F2. So the question says, two forces act on the hook shown in the figure below. Specify the magnitude of F2 and its coordinate direction angles so that the resultant force Fr acts along the positive y-axis and has a magnitude of 800 newtons. So you have a drawing here, F2, that makes the angle in between y and z axis. F1, which is 300 newtons along the x and y axis, making a long angle 45 degree to the x axis and 60 degrees to y axis. And to z axis, it makes 120 degrees. So for F2, there is no directions and magnitude. We are going to find that those two for the force 2. So formula again, the resultant force for the Fr is F1, the addition of force F1 plus force F2, or the vector F1 plus vector F2. In the Cartesian form, substitute again, F1 should be equal to F1 cos alpha 1 I, F1 cos beta 1 j plus F1 cos gamma 1 k. We are just substituting the formula that we have here. This one, we are just substituting the formula. So it's essential to memorize these formulas. So after this, just substitute the value that we have. F1, it's given 300 newtons. Cos alpha, that means the angle made by the vector to the x-axis, that is to the x-axis, 45 degrees. Substitute. F1 cos beta, beta, the angle made to the y-axis, that is 60 degrees. Substitute again here. F1 given 300. So here also F1 300 cos gamma, that is the angle made by the vector to the z-axis, that is 120. So just substitute. So when you substitute and solve, you will get the answer, that is F1 should be equals to 212.2 I plus 150 J minus 150 K newtons. So F2xi, then that's F1. So for F2 also same process, F2i, I plus F2. F2, did we find F2? No. So we have FR. Do we have FR? 800 kilojoule or 800 Newton is given because it's mixed along the y-axis. So here FR is 800 J newtons because it's making along the y-axis only. So the coordinates for x-axis and z-axis should be 0. So FR given. So by using this formula, we can find the F2. F2 should be equals to FR minus F1. That's what they did here. It's a formula here. By using this formula, we can find FR, substitute 800J here, then F1, this one, substitute, F2, this one, substitute. After substituting all of the values for F1, F2 and FR, you will get the answer of, make sure that it's segregated I, J and K. So to satisfy this equation, I, J and K components of FR must be equals to the corresponding I, J, K components of F1 plus F2. So substitute the values, the one you got from here, these ones. So how? Here F2x should be, that is 212.1, so satisfied. Another is 800, 150 plus F2y, so F2y is equals to 650, which is 800 minus 150. Then another equation that we have is 0 is equals to 100 minus 150 plus F2z. So F2z, 150 minus 150 will transpose to the left hand side. So that is F2z should be equals to 150 newtons. That means satisfied. Then the last question, this example number 8 is asking is the coordinate direction angles. So that one, magnitudes. So magnitudes of F2 is thus can be solved by F2 equals to square root of this one. So that should be equals to 700 newtons. For this one, we are again using the formula here. The square of component along the x-axis plus the square of component along y-axis plus the square of component along z-axis, then square root of it. Next we have is example position vector. So position vectors usually use the slope or the distance, or also possible we can say coordinates. So position vectors R is defined as a fixed vectors which locates the point in space relative to the another point. So it will use the coordinates x, y, z, that is point P. K unit vectors along y is j, I along x is I, and along z is k. Then the resultant vector R is R, and making at a certain point P with the coordinates x, y, and z. So same here. So we have two vectors RA, RB. It will make a coordinate XA, YA, ZA, XB, YB, ZB. So you can check the picture clearly, diagram properly. So for problem solving, you can memorize this and it will be easy for you to memorize. So using the triangle law in the position vector, the same resultant vector R should be equals to RA plus R should be equal to RB. So check the directions, the arrows, because they are essential. Then solving for R, the expression RA and RB in Cartesian vectors form a yield. R should be equals to RB minus RA. Then again, use the Cartesian vector components along unit vectors I, j, k for the vector vector b minus for vector ra. Just substitute, then solve. After solving, you'll get the answer I xbi minus xai. So we can segregate and take a common, that is I. Same here, ybj minus yaj here, jb minus ja, that is jb minus jak. So you get the answer as well. So for that, we have example number 9. As per example number 9, is asking an elastic, the rubber band is attached to the point A and B shown in the figure. So A is the point which is below x-axis, 3 meter below x-axis, and from z-axis it is 1. So the coordinate is 3, 0, 1. So determine its length and its direction measure from the A towards B. So B coordinate is from x, that is 2, y is 2, z is 3, yes, from y 3, z is 2. Yeah. So coordinates for A, 1 meter, 0, minus 3. Check the direction also, going down. So G is negative. For the B, up, away. So minus, plus, plus. So R should be from the formula that we have here. This one, just copy it and substitute the value that we have. R is R xb minus xa, xb, that is minus 2, xa 1 here, yb minus ya, yb 2 meter minus ya 0, 2 minus 0, zb 3 minus za 3. So here minus minus, so it should be plus. So 3m minus minus plus 3 meter, so it's 6 meter. So the common is meters, so you can just solve. R should be equal to minus 3i plus 2j plus 6k. So we are not yet done because the question is asking to determine the length and directions. We just got the coordinates. So by using those components, minus 3 plus 2 plus 6, substitute in our formula. R should be equal to root under minus 3 square plus 2 square plus 6 square. That should be equal to 7 meters. So that is our length. After determining length, we are supposed to find the direction, measure from A towards B. To find that one, we have a formula again. Alpha should be equals to cos inverse here 115.38 degrees, beta, that is cos inverse 2 over 7, that is 73.40, gamma, that is cos inverse 6 over 7, that is 31 degrees. So these are the answer as well. So next we have here is a force vector directed along the line. So if the force vector is directed along the line, the formula you will copy the same again. F force vector F should be equals to unit vector. So Fu. So U, that is vector over, when it is a unit vector, it is always vector over magnitude. So you can just solve it and substitute the value R. We get the vector R from here, this one, vector R. The next is the magnitude. For magnitude, root under this formula. That is where we got. So the last example, the example number 10, the man shows in the figure pulls on the cord with the force of 70 pounds, representing this force acting on the support A, here in the support A, as a Cartesian vector, and determine its directions. So the values are given: the distance from object, the distance from the axis, x-axis, y-axis, and z-axis, it's given. So here r is 12, because from x-axis the person is 12 meter away, y-axis, that is from y along the y-axis 8 meters, z-axis 6 feet. So that's why 24. Okay, because 6 feet is below, so 30 minus 6 feet, that is 24 feet. So that's why we substitute the value. And the magnitude r is same again, get 12 square minus 8 square plus minus 24 square, then square root, so it will be 28 feet. Then forming the unit vectors that defines the direction and sense of both r and the vector f, we have u equals to vector r over magnitude r. So vector r 12 over 12 square, 28, the magnitude we already solved, that is 28, minus 8 over 28 minus 24 over 28. Then fu, you got the unit vector, this one, substitute here. So f, we already have a f, that is 70 pounds. The person is applying 70 pounds, that is the force. So just substitute here 70 pounds times unit vector. Unit vector, we found it here. So solve 70 times 12 over 28, that is 30. 70 times 8 over 28, 20. 70 times 24 over 28, that is 60 pounds. And the last one, we are looking for the angle. Cos alpha, you can get cos inverse 12 over 28. For the beta, angle beta, cos inverse minus 8 over 28. For the gamma, cos inverse minus 24 over 28. You will get these angles: 64.6 for alpha, for the beta 107 degrees, and gamma it's 49 degrees angle. So that is the directions. And the last topic for this chapter is the dot product. Dot product of the vector A and vector B can be written A dot B and read as A dot B. Unlike the addition vector or the multiplication of vector, if it is multiplication of the vector, whether it is A multiply B or B multiply A, it's the same. But in terms of dot product, A dot B, they are not same with B dot A. So A dot B is defined as the product of magnitude of A and B and the cosine of the angle theta between their tails. A dot B can be equals to AB cos theta. So you will just solve this one. When you solve, AXI times BXI, AXI times BYJ, AXI times B2K. Similarly, you will solve each of the component with each of them. So when you solve that one, the final answer will be A dot B should be equals to A dot AX BX plus AY BY plus AZ BZ, because some of these things it will be cancelled. And the angle formed between the two vectors or intersecting lines can be solved by using same theta equals to cos inverse vector A dot B divided by the magnitude of vector AB. So if A dot B is equals to 0, theta is equals to cos inverse 0, it should be 90 degrees. so that A will be perpendicular to the B. And components of the vector parallel and perpendicular to the line, A alpha should be equals to A cos theta. A alpha, because here sin cos theta is equals to base upon hypotenuse. Base is A alpha A. So when you cross multiply, you will get A alpha equals to A cos theta. And the simple examples: determine the magnitude of the projection of the force F shown in the figure below. Here, projection, simple, just substitute with the formula. Here, A alpha is equals to A cos theta. Yeah. So that's all for the chapter 2. If you have any questions, you can ask so that I can further explain more. Okay, thank you. This will be all for the chapter 2.